All right, so today, guys, we're going to have a look at the argument of z, or arg-z. So what is the argument of z? You may have heard this term before, or you may not have. Basically, the argument of z is the angle between the real positive axis, so that's this axis here, and our z, our vector there. So that angle theta. So that's what it is, and we're also going to have a look at how to work it out. So find arg z for z equals to -3 minus 3i. So I just did a quick sketch, drew some axes there. I did, so we know that our real axis is here, traditionally our x, but it's our real, and our imaginary is our vertical axis. So if I went to -1 to 3, -3, -1 on the imaginary axis, so -1 there, that point there is going to be my angle. So what I'm going to do is, when we're talking about the arg z, we're talking about the angle from the real all the way around to our vector. So that's our theta. Okay. What we're going to do is look at this angle here, because we know it's 180 degrees from the real all the way to the negative real axis, and then we've got this extra little bit. If we zoom in on that little bit there, it goes down 1, that -i, and across 3. So that's 1, that's 3. And that is our z. So our argument is this angle here, plus that 180. So what we've got is we've got the opposite. So we know if we have a right angle triangle, we know that opposite the angle is our opposite. Next to it is the adjacent. We also know this is right angled. And our hypotenuse is that z. So if we have a look at we've got the opposite and the adjacent. So thinking back to our SOHCAHTOA. All right, we've got the opposite and the adjacent, opposite hypotenuse, adjacent hypotenuse, opposite adjacent. So we're going to use this one, T, for tan. And that's going to be true for all of these cases. So what we're going to do is tan of our angle, theta, equals opposite 1 divided by adjacent 3, which means our angle equals the inverse tan of 1 over 3. And we just slide that one into our calculator. So if we put that in our calculator, we get an answer of 0.22 radians. So 0.322, I'm reading my screen wrong, radians. All right, and we remember we also have this 180 degrees. We know 180 degrees equals pi radians. So we get pi plus 0.322, and we should get an answer of 3.46 radians. Okay, and that's the argument for this. Now another way to represent this is if we had to look at the angle back the other way, if we call that theta, so it's the angle from there to our line, we could represent this as this. It's the same thing. This is equivalent to negative, because we're going back the other way, 2.82 radians. Okay, if we're going the other way around, but the way we did it first is most correct. All right, so hopefully we can do some arguments now. Thank you.